So hi everyone, we're back now at the Hive configuration section 3, where we're looking at external and internal Hive tables. So from the previous task we had imported our data into internal tables, which means that the data is stored as files inside our user Hive warehouse directory. Now the implications of creating internal tables is that the table data and the metadata are stored within the Hive MySQL meta store. So the table data is stored under user Hive warehouse directory, and the metadata associated with that table data is stored in the meta store, which is hosted by the MySQL server. Now, once the source file is imported to Hive, it will be deleted from the source directory, and we've seen that from the last exercise. And if you drop the table in Hive, the data and the metadata will no longer be available. So decisions regarding internal and external tables in Hive, you should consider these particular points. With the external table, the data is not deleted when you import the data into a Hive table. The data is not stored in the default directory, it can be stored in any location, and when you drop the table in Hive, and if you drop an external table in Hive, it only deletes the metadata link. The source directory will still remain intact. So what we want to do is just perform this exercise here, and this will help us to understand exactly what happens when we're using external tables. So what we want to do is, from a Linux command prompt, create 3 text files with the following format: ID, name, age. For example, 1 Thomas, colon, comma 34, and 1 comma Anne, comma 35. So ID, name, and age, just 3 sample text files, and we will store them in under user Hadoop as test1, test2, and test3. So if we go to our command prompt, Linux command prompt, and create test1.txt, and in here just create some sample data. Okay, so that's one file created. Just create another file with ID 44, Thomas, and age is 90, ID 34, and name is Tommy, and his age is 67, and ID is 10, with name William, and his age is 56, and then create another text file. So ID is 77, his name is Paul, and his age is 35, and then we have ID 76, name is Cora, and she is 12. So there's our 3 text files. So what we want to do now is put those 3 text files up to our user Hadoop HDFS directory, and I didn't tell them what file to put up. Yes, put test1.txt, test2, and test3. So these 3 files are on our HDFS file system. So we want to create an external table, this time through the Hive shell. So let's create external table, if not exists, just to be on the safe side, ext people, and ID is an int, name is character of 30, and age is int. Comma, sorry, comment is data about people, and row format delimited, fields terminated by a comma. So row format delimited fields terminated by a comma, so this can be comma or it can be semicolons, and it's going to be stored as a text file. Stored as a text file, and the location is going to be user Hadoop in quotes, semicolon. Okay, then at the Hive shell, you can run the command select asterisk from external people, and all the files should be included in the result set. So select asterisk from ext beople. Okay, I think I have extra data in there, so I should have really put them into a directory of their own. So I might just go ahead and do that. So let's do test ext test 2 and test 1. So go ahead and create this file or this external table again. So create table if none exist. The comment is data by people. Row format delimited field. Fields is the comma and stored as a text file. Location is test, just double checking, is test ext. And let's do a select. Still looking for my table. Okay. So at this point what we should do is drop the table and recreate it again in Hive. So let's drop table ext people. Drop table ext people, and that'll drop it, and then recreate it again, specifying the new location. So create external table if not exists ext people. So ID is int, name is character of 30 spaces, and age is int. Comment is data about people. Row format delimited fields terminated by a comma, stored as a text file, and location this time is user Hadoop test ext. Okay. And then we can do select asterisks from ext people, and you can see all our CSV files have been amalgamated into one external people table, which is quite useful. So basically you just append your files, your CSV files that match the format of that table, external table, into the one directory, ensuring that no other files or directories are located in that particular directory. And then when you do a select from that particular table, then you will get all the data amalgamated together under one external table, which is quite useful. What you can do is you can create an internal people table from that. So create table internal people, and again ID is int, name is character of 30 spaces, and age is int. Row format delimited fields terminated by a comma. Row format delimited fields terminated by a comma. And this time we're storing it as ORC, which is our row columnar type of format, which is very efficient. Now we can insert data using the following command here. So what we're going to do is we're going to take the data from the external table and bring it into an internal table. It's stored as a row columnar format, which is very efficient when we're selecting from specific columns. So insert overwrite table internal people, select asterisks from ext people. So that'll go ahead and take the data from the external table and put it into the internal table, which is stored as OCR. So the internal table, when it's created, will be stored under user Hive warehouse. So it is managed completely by Hive. So if you drop that table, it is completely gone. So just be careful with that. Okay, thank you.